Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 31, JAMB Physics 2018, and the question goes thus. A satellite moves in a circular orbit of radius 4r around the Earth. The acceleration of the satellite in terms of g is. There is a formula for the acceleration of the satellite, which is a equals gm over r squared. The g is the gravitational constant, okay, while the m is the mass of the central body which the satellite orbits. Okay, then the r is the radius of orbit for the satellite. Okay, so we were given in the question that the radius is 4r, so let us impute that. So we have gm over 4r squared. Okay, so now we have gm over 4 times 4, or 4 squared is 16, then r squared. Alright, then we need to remember that g is equal to gm over r squared. Okay, and that would bring us to splitting this up. So we're going to have gm r squared times 1 over 16. Okay, good. So now this is what we're going to have. So this is going to represent g. So we have g times 1 over 16 will give us g over 16. So this is acceleration in terms of g. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm glad to have you here again. This is question 32, JAMB Physics 2018. And the question goes thus. And the diagram above, the direction of the force between north and south in the magnetic field is. First, I would like us to pay attention to some key important features that this diagram shows, that this diagram depicts. Okay, so the first one is that the magnetic field lines never cross each other. Okay, so we can see the magnetic field lines that never crossed each other. All right, good. The next is that the closer the lines, the stronger the magnetic field. The closer the lines, the stronger the magnetic field. Alright, good. Then the third observation is that the lines have arrow heads. Okay, to show the direction of the force exerted by a magnetic north pole. Okay, good. It shows the direction of the force exerted by a magnetic north pole. As you can see that the lines have arrowheads showing this. Okay, then fourthly, we also note that these arrowheads point from the North Pole to the South Pole. Okay, good. So now let's go to the question. Alright, so in the diagram above, the direction of the force between north and south in the magnetic field is option A, MP. I don't know what that means. Okay, so this is wrong. Option B, south north, not at all. Option C, north south. Exactly. Okay, the arrowheads point from the north pole of the magnet to its south pole, showing the direction of the force exerted by the north pole. Alright, so option C is correct. Thank you for watching. See you in the next video. Bye bye. Hi, I am Kemi. I'm glad to have you here again. This is question 33, JAMB Physics 2018, and the question goes thus. At what frequency would a 10 Harris inductor has a reactance of 2000 ohms? There is this formula for finding inductive reactance, which is equal to 2 pi f frequency and L inductance. So we are looking for the frequency, so we're gonna make frequency the subject of the formula. So we have XL over 2 pi L, and then the question, we already given some values. We have the reactance, which is given as 2000 ohms over 2 times. We are calculating or working in terms of pi, so we're not going to change that value. Then for the inductance, we're given 10 Harris. So now we go ahead to cross out 0, we cancel 0, 2 into 1, 2 into 100 is 100. So we are left with 100 over pi hertz. Okay, so this is the value of frequency. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 34, JAMB Physics 2018, and the question goes thus. What force has to be exerted on the mass 60 kg to give it an acceleration of 10 meter per second square vertically upward? Okay, the force that has to be exerted, F, is equal to the upward force, which is mass times acceleration, plus the gravitational force, which is mass times gravity. Okay, so now we substitute the different values. For the mass, we were given is 60 kg, so we have 60 times the acceleration as given on the question, which is 10 meter per second square. Okay, good. Then in the gravitational force, the mass, which still remain the same, which is 60, then plus the gravity as given in the question, which is 10. Okay, so now we go ahead to solve. 60 times 10, that gives us 600, plus 60 times 10 again, which gives us 600. So finally we have force equals 1200 Newton. So this is the amount of force that will be exerted on the mass to give it this acceleration vertically upward. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Kemi. I'm excited to have you here again. This is question 35, JAMB Physics 2018, which goes thus. A satellite revolving around the Earth is kept on its orbit by First, let's take a look at the concept surrounding this. Okay, good. So some people confuse centrifugal force with its counterpart, centripetal force, because they are closely related, and one might say that they are two sides of the same coin. So first, let's talk about the centrifugal force. This is defined as the apparent force that is equal and opposite to the centripetal force, drawing a rotating body away from the center of rotation caused by the inertia of the body. Okay? Why centripetal force is defined as the component of force that is acting on the body in a curvilinear motion that is directed toward the center of curvature or axis of rotation. However, note that the centripetal force is an actual force, while the centrifugal force is defined as the apparent force. So both of these forces are working to keep the satellite revolving around the Earth. So both of these forces are working together to keep the satellite that is revolving around the Earth kept in its orbit. Okay, so let us take a look at the answer options. Option A says centrifugal forces only, not correct. Option B, centripetal forces only, not correct. Option C, centripetal and frictional forces, not correct. Option D, centripetal and centrifugal forces. Yes, this is correct. So answer option D is the right answer. Thank you for watching. See you in the next video. Bye-bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 36, JAMB Physics 2018, which goes thus. The plates of a 0.5 microfarad uncharged capacitor are connected to a 10-volt battery. The charge on the capacitor after a long time is... So there is a simple formula for solving this question, which is Q equals CV. The Q is charge in coulomb, while the C is the capacitance in farads. Then the V, which is the volt in volts, the voltage in volts. Okay, good. So we already have some of these values in the question. Okay, so Q, which is unknown, then for the capacitance, which is measured in farads, we have as 0.5, okay, times the volt, which is given on the question. The volt of the battery is 10. Alright, so by the time we multiply these, we have a final answer as 5 microcoulomb. Okay, good. So this is our final answer. So the answer option D is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Willie Kemi. I'm so excited to have you here again. This is question 37, JAMB Physics 2018, and the question goes thus. If a document is to be produced using a duplicating camera, where should the document be placed in order to obtain an exact copy? Okay, the lenses of a camera is a convex lens. Okay, so we're going to make use of a quick diagram that would help us to illustrate this. Okay, all right. So now I want to draw the lens, and now be that perfect just for illustration. Okay, so this is the center, this is F, and this is 2F. Okay, then on the image size we also have F, and we also have 2F. So when the image is located at 2F, say this is an image, okay, at 2F point, the image will also be located at 2F point on the other side of the lens. In this case, the image is upside down image. Okay, the dimensions are equal. Okay, the dimensions in terms of the height are both inside and outside of the lens, they are the same. The dimensions are equal to the object's dimensions. Okay, so if the object is 5 inches, the image too will be 5 inches. Okay, good. That is to say that the absolute value of magnification is exactly 1. Okay, so if the object is 5 inches, the image too will be 5 inches. Alright, so now let us go back to the question. Alright, so the answer options, we have answer option A at the point which is twice the focal length of the lens of the camera. Exactly, this option is correct at the point which is twice the focal length, that is 2F. Okay, that is when we can have the document to produce or obtain the exact copy that is of the same dimension. Alright, good. So answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm excited to have you here again. This is question 38, JAMB Physics 2018, and the question goes thus. The efficiency of a machine is 70%. Calculate the work done using this machine to raise a load of 10 kg through a vertical height of 2.0 meters. Okay, there is this simple formula for calculating the efficiency of a machine, which is N equals to energy output over energy input. Okay, times 100. Alright, so now let us simplify further. The N is efficiency of the machine, which we already have. We're given as 70. So let's substitute that in immediately. Then for the energy output, which is, okay, let me write that out, mgh, that is mass times gravity times height, okay, over the energy input. Let us just represent that with EI, okay, times 100. Alright, so now let us substitute the values for mgh. So we have 70 equals the mass we're given, which is 10 kg. So 10 times the gravity, which is also given in the question as 10, okay, then times the height, which is given as 2.0, to be divided by energy input, then multiplied by 100. Okay, so now let us make EI the subject of the formula. So if we cross multiply, we have EI, that is the energy input, equals 10 times 10 times 2 times 100 will give us 20,000. So it is 20,000 to be divided by 70, okay, and this will give it, let us quickly use a calculator to do that. So if we have 20,000 to be divided by 70, we have 285.71, okay, 285.71 joules. That is the energy input, okay. So if we check the answer, there is no appropriate answer in the given option, but this is the correct answer, okay. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Oluwakemi. I'm so excited to have you here again. This is question 39, JAMB Physics 2018, which goes thus: which of the following statement is not true about atoms? So we're going to go through the options to verify which one is incorrect. So option A, atoms of different elements have different atomic weights. Of course, each element have unique properties, okay, they all have unique properties in terms of different atomic numbers. So this will also affect the atomic weight, making it to be different from each other. So this is correct, okay. The next option, the mass of an atom is concentrated in the nucleus. This also is correct because the mass of an electron is very small compared to proton or neutron. And since nucleus contains proton and neutron, most of the mass of an atom is concentrated in the nucleus, okay, so this is correct. Option C, an atom is made up of nucleus and a number of electrons. This also is absolutely correct. In the nucleus, you'll find the proton and the neutrons, okay, and you will also find the electron, okay, the outermost shell. So these are the three particles that made up an atom. So this also is correct. What about the last option? Atoms of all elements are identical. Atoms of all elements are not identical. In fact, the number of protons in an atom is a defining feature of an atom. It makes an element different from another element. Okay, so the number of protons in an atom is also called the atomic number. Okay, so answer option D is not a true statement about atoms. So this is the correct answer. Thank you for watching. See you in the next video. Bye bye. Hi, I'm Olu Kemi. I'm excited to have you here again. This is question 40, JAMB Physics 2018, and the question goes thus. A current of 20 amps flows through a cable whose resistance is 5 ohms. Calculate the electric power dissipated. This is a very straightforward calculation with a simple formula, which is P, the electrical power, is equal to the square of the current times the resistance measured in ohms. Okay, so already we're given the value of the current, which is 20 amps. So we input the value, which is 20 square, okay, times the value of the resistance, which is given as 5 ohms. Alright, so now we simplify further. So 20 square will give us 400 times 5, and this will give us a final answer of 2000 watts. Okay, good. Then let's check the answer. The answer option A, 2 times 10 raised to power 3, is the same as 2000 watts. Okay, so the answer option A is the right answer. Thank you for watching. See you in the next video. Bye bye.